Alright, so we are going to solve this problem that says black holes are suspected when a visible star is noticeably being pulled by an invisible partner that is more than 3 times as massive than the Sun. If a red giant dying star is gravitationally accelerated at 0.075 meters per second squared toward an object that is 9.4 times 10 to the 10th meters away, how large a mass must the unseen body possess? So we have two masses. We'll call this one the unseen body or unseen mass. And then we have another one. And in between them, the distance is 9.4 10 to the 10th meters away. For this problem, we're going to need the equation G equals G big M over the distance squared, where, remember previously, we had the form of the equation mg equals little m big G m over the distance squared. So the force of attraction between them was equal to G times the mass of the two bodies over the distance squared. And to get to this equation, we had canceled out the little m. So the acceleration due to gravity for the little m could actually be figured out from the mass of the big M, or the other mass, times the gravitational force constant over the distance between them squared. So what G is this? This G is the one that they're giving us in the problem. So the force, the gravitational force going towards the unseen mass for the dying star, this is the dying star, its little g is going in that direction at 0.075 meters per second squared. So we know little g, we know d, we know big G. We need to solve for the mass of the unseen body. Mass of the unseen body. So let's rearrange this equation. G times the distance squared over big G equals M. And we can do that math over here. I'll rewrite the equation once more. M equals G times D squared over big G. Now let's plug in some numbers. Little g, they said, was 0.075 meters per second squared. The distance squared is 9.4 10 to the 10th meters. And that's all divided by 6.67 times 10 to the negative 11th Newton meters squared per kilogram squared. The answer, plugging these numbers into our calculator, let's start with 0.75 times 9.4 10 to the 10th squared divided by 6.67 10 to the negative 11th. And you're going to get a really big number. 9.93 times 10 to the 30th.